Hi y'all, and welcome to your last new topic in the rationals unit. I know you're probably super excited to almost be done with this awful unit. This is about graphing, so we're going to look at things like asymptotes, transformations, domain and range, holes in your graph, and doing simplification. So a lot of this is not new. The new part is the being able to simplify a rational expression. So a hole, here's the general form. Before I get started on that, it's your general form. A hole happens when two factors cancel. So before we were looking at simplifying rationals and factoring them to make things cancel. When you do that, that cancellation, it causes a hole in the graph, meaning that you have like a solid line and then you have a hole and then the solid line continues. So there's like a break in your graph. H, so let's see if I can highlight it. H in blue, that is your vertical asymptote. And just like in normal transformations, it's going to move the graph left or right. A, so that number that's on the top, that it will be in green. A is going to move you vertical stretch or vertical shrink, so it's the numerator of whatever your fraction is. K is going to be the horizontal asymptote, and it's going to move your graph up or down. So there's K in the back. Okay, the B that you see in the front of the X in parentheses, we're not going to be doing that in Algebra 2, so you don't have to worry about that. I just put it there because it's part of the general form. So a really famous acronym that is used, Bobo Botten eats DC. So Bobo, this is in regard to horizontal asymptotes. I just spelled horizontal wrong. Good thing I'm a math teacher. Okay. So it's not going to work for vertical ones, just horizontal. Bobo means if the degree of the exponent is bigger on the bottom, then your horizontal asymptote is going to be y equals 0. Botten is if the degree of the exponent on the top is bigger, then you have no asymptote, no horizontal asymptote. Eats DC means if each are the same, meaning the biggest exponent of the top and the bottom are the same, then you divide the coefficients. We're really only going to be using Bobo and Botten. When you get into pre-cal, you'll see this a lot more. So let's look at number 1 with this general information that we have. I want to identify the asymptotes first. So where it says equations of asymptotes, where it says x equals, that's going to be talking about your vertical asymptote, and y equals is your horizontal asymptote. The equation of a vertical line, vertical goes like this and horizontal goes like this. So a straight up and down line is x equals, and a line that goes side to side, like left to right, is y equals. So this number, this 5, is your h. And remember that your h always flips sign. So here it's a positive 5. So when I write my vertical asymptote, it's going to turn into a minus 5 because I'm flipping the sign of whatever h is. So I'll put a little parentheses h. K is your horizontal asymptote. So the -4 that's here, that's your k value. So I have a horizontal asymptote at -4. I'm going to go ahead and draw those out. So you've got vertical asymptote at -5, horizontal asymptote at -4. Okay, and I'm going to just do a rough sketch of the graph. So we know what our parent function looks like. So your graph is going to look something like this. Okay. For domain and range, your domain is talking about x values. So we're going to be looking at the vertical asymptote to look at our domain. Your range talks about the y values, so we're going to be looking at the horizontal asymptote. For my domain, my vertical asymptote is at -5. It's going to kind of create a jump in your graph. So I have a little piece of the graph here. So that is going to generate -infinity to -5. And then the other half of the graph, I'm going to put union -5 to infinity. So pretty much for every question in this portion, you're going to put for the domain -infinity to whatever the vertical asymptote is, and then the vertical asymptote to positive infinity. For the range, we're going to do the same thing. I'm going to go -infinity to my horizontal asymptote, which is at -4, union -4 to infinity. And this is my horizontal asymptote. Okay, so those asymptotes are kind of generating a break in the graph. The union symbol means that I'm piecing together those breaks. You're always going to put parentheses around asymptotes and infinity signs. You are never going to put a bracket. That means we're including that point, and we don't want to include the point. For the question that asks about holes, we didn't have to do anything to simplify this function. We didn't have to cancel anything, so there are no holes in this graph. Okay. For some reason, mine doesn't have it on here, but yours does, about describing the transformations. So my a value here, I'll rewrite the equation so it's easy to see. Okay, your a value here is 3. So the number on the top, that's your a value. Your h value is -5. Remember that h is always the opposite sign from what you see. So if you see a +5 in your equation, that means your h is going to be a -5. And your k value here is -4. That sign does not flip. Okay, so given this, I have a vertical stretch of 3, and that's coming from the a value of 3. I'm going to move to the left 5 units, and that's coming from the x plus 5. And I'm going to move down 4, and that's coming from your k value. So this is a, this is h, and this is k. Okay, transformation should be fairly easy for you, I hope. We've been doing this with every function, even since Algebra 1. So I hope that part is not super difficult for you. All right, number 2. On this one, we are going to have to do some simplification. So notice at the bottom is a quadratic. Whenever we see a quadratic, we want to factor it. So I want to try to factor 2 on the top and 3 on the bottom. My factors are going to be 2 and 1. So I'm going to have x plus 2 times x plus 1. So all I've done here is I've taken what's on the bottom and I factored it so it's in this form. Now notice that you have an x plus 1 on the top and on the bottom. So I'm going to go ahead and cancel those out, and I'm left with 1 over x plus 2. Okay, so that is my fully simplified function. Notice that I canceled x plus 1. The whole is generated by whatever value would make that 0. So if I want to solve this, it's just like when we were looking at what we're going to exclude from the domain. We would put whatever got canceled is not equal to 0, because I'm trying to figure out what value of x would make the denominator 0 or would make that whole equal to 0. So by solving it, you're just going to flip the sign. So x is not equal to -1. So for the whole, I'm going to put x is not equal to -1. Now here's the fun part. In order to actually figure out the coordinate point of the hole in the graph, you have to evaluate that x value of -1 in your function. When we do this in class, we did it with a calculator, and I had you graph this and then just hit Control T. That's what we're going to do in general. I just don't have the ability to throw your calculator up onto this video, so I'm going to do it by hand. Essentially what you're doing is you're taking the simplified function, so that's my simplified function, and instead of putting an x, I'm going to substitute it with that -1. So this is going to become 1 over -1 plus 2. So I have 1 over 2 minus 1, which is 1, so I get 1. So my whole would be at -1, because that's the x value that generates the whole, comma 1, because that's the y value that I just found by putting -1 into my function. So that is actually where the whole is going to be. So I'm going to go ahead, -1, 1, and I'm going to draw an open circle there. Okay, that signifies that there's a hole in your graph. For your equations of your asymptotes, remember that x equals is your vertical and y equals is your horizontal. So my vertical asymptote is determined by whatever is down here. So I've got a +2 down here. That means that my h value is actually -2. So my vertical asymptote is going to be at x equals -2. I'm not adding or subtracting anything after this fraction. I just have one fraction. There's nothing behind it. So think of it kind of as like 1 over x plus 2 plus 0. So that 0 that's there, that is your horizontal asymptote. And we can use our acronym here. Notice that the degree of the numerator, the highest power of x, so I'm looking at this original function, the highest power of x there on the top is 1. The biggest exponent on the bottom is a 2. So this would be bigger on bottom, which means that your y is equal to 0. Or you can think of it, I'm not adding or subtracting anything to the fraction, so my horizontal asymptote is at 0. So I'm going to go ahead and draw those in. So I've got a vertical asymptote at -2, and I've got a horizontal at y equals 0. Okay, then I'm just going to let those asymptotes kind of guide where my graph goes based off the parent function. So I'm going to go here. I'm not going to draw a line through that because it's a hole in the graph. The graph is not actually going to be evaluated at that point. And I've gotten their curve here. Okay, so my domain, remember this is based on the vertical asymptote, and the range is based on the horizontal asymptote. So my domain goes from -infinity to my vertical asymptote, which is -2, union vertical asymptote to infinity. So this is vertical asymptote, vertical asymptote. The range goes from -infinity to your horizontal asymptote, union horizontal asymptote to infinity. Okay, transformations on this one. I know that there is a 1 on the numerator, so you're looking at this function for transformations. The 1 on the numerator does not tell you that you have a vertical stretch or a vertical shrink or anything like that, because your parent function is 1 over x, and that has no transformations applied to it. So numerator in the parent function is 1, numerator here is 1. We have no vertical stretch or shrink or anything like that. The only thing that's happening here is this +2. So if my h is equal to -2, remember we always flip the sign on h, I'm going to be moving to the left 2. And that's the only transformation that's happening there. Okay, let's move on to page 2. So for number 3, we need to simplify this before we can do anything. So notice that on the bottom, you have a GCF of 5 that you can take out. So if I divide both of those terms by 5, I'm going to have x plus 3. Notice that I put a 5 on the outside of parentheses. Whenever you divide a number out, whenever you take out the GCF, you need to leave it in the front of the parentheses, and then the result of your division goes on the inside of the parentheses. Okay, so I've got this. Now, remember that 10 can be written as 5 times 2. I can break that into 2 separate products. So instead of writing 10 on the top here, I'm going to change it, and I'm going to write it as 5 times 2. Okay, I can now get this 5 and this 5 to cancel out with each other. You're not going to have anything like that on your test, but just as a way to make you think outside the box, that's a fun trick that you can use. So now you're left with 2 over x plus 3 minus 3. Do not combine the plus 3 that's on the bottom of the fraction with the minus 3 that's on the end of the fraction. You cannot combine those, so just leave it as is. So this is your fully simplified function, okay? As far as wholes go, -5 or 5 is not a whole because it was not x plus a number or x minus a number. 5 is just 5. There's nothing I can do to make 5 equal to 0. So 5 or -5 is not a whole. So for wholes, we have none because we didn't cancel any factors that were x plus a number or x minus a number, okay? So let's look at asymptotes. So the plus 3 here, remember that this is my vertical asymptote, and the minus 3 in the back, that is your horizontal asymptote. So I've got vertical asymptote, horizontal asymptote. So since I have a plus 3 in my equation, that means that your h value flip sign is actually -3, so x is equal to -3. Your horizontal asymptote is also at -3. So I've got an asymptote here, and I've got an asymptote here. Okay, so I'm going to go ahead and draw my function. It's going to look something like that. My domain depends on vertical, and my range depends on horizontal. So domain, I'm going -infinity to the vertical asymptote, which is at -3, union vertical asymptote to infinity. And since your domain and range both include that same asymptote, the domain and range are going to be the exact same. Okay, so that's what you got. For transformations, this is the function that we're looking at. Okay, so my a value is 2 because that's the number on the top of the fraction. My h value is -3 because that's on the bottom of the fraction connected to the x. That value always changes sign. It flips to the opposite sign. And the number at the end is my k. So k is -3. Okay, so my a value of 2 is going to cause me to have a vertical stretch. It's a stretch if that value is bigger than 1. The h being -3 is going to make me move left 3. And k being -3 is going to make me move down 3. Okay, number 4. It's a fun one. So this one involves some hardcore factoring. On the bottom, you've got this x squared minus 64. That is what I want to factor. The top where you have the 3 in the parentheses x minus 8, do not distribute the 3 there. Just leave it as is until we factor, okay? So I need two numbers that are going to multiply to -64. And since there's no single x term here, it's going to have to add or subtract to 0. So those numbers are 8 and -8. So this is going to become this. Now notice that you have an x minus 8 on the top and the bottom of the fraction, so I can cancel those out. So you've got 3 over x plus 8 plus 1. Again, do not try to combine the 3 on the top or the 8 on the bottom with the 1 that's after the fraction. Just leave it as is. That is your fully simplified form. Okay, so my plus 1 in the back, that's going to be my horizontal asymptote. My plus 8 here is going to be my vertical asymptote, but remember it's going to flip sign. So I have a vertical asymptote of x equals -8 and a horizontal asymptote of y equals +1. Domain, going from -infinity to the vertical asymptote. and range going, or sorry, I flipped this. There we go. VA. Range is going from negative infinity to the horizontal asymptote. So I've got -8. I'm just going to put it somewhere out here. The graph is too small. It doesn't include that. And then 1 is going to be up here. Okay, so our graph is going to have a hole in it. I canceled the factor x minus 8. That is what I canceled. So to flip the sign there, x cannot equal positive 8. Again, you would just do this in your calculator. You would evaluate the simplified function. You would hit Control T, and then you would find an x value of 8 and get your corresponding y value. Since I can't use the calculator here, I'm just going to do it by hand. So instead of putting in an x, I'm going to substitute it with an 8. Okay, so I've got 3, 8 plus 8 plus 1. I've got 3/16 plus 1. You don't have to pay attention to the fraction work, it's okay. So we get 19/16, and we're going to leave it like that. So 19/16 is like a little bit bigger than 1. So your whole would be at 8, 19/16. Okay. So 19/8, or 19/16 is a little bit bigger than 1. So I'm going to go over 8 and then up a little bit further than 1. So my whole is going to be about right there. So our graph is going to look kind of funky. It's going to look like this. Ew, that was really ugly. I'm sorry, guys. And like that. Okay, so that's what your graph is going to look like. So describing the transformations, you have this function. Okay, so the number on the top, if A is 3, that means that I have a vertical stretch. The number attached to the x, so this plus 8, is your h value, but it always changes sign, so this is actually going to move us to the left 8. And the plus 1 in the back is your k, so that's going to move me up 1. If you've stuck with me this far, thank you very much. At this point, if you feel like you want to go ahead and try to do these examples on your own, feel free to, and then come back and check. Or if you want to do them with me, just stick with me and we'll work through these together. So for number 5, we need to factor. Notice that you've got a quadratic on the bottom, so I'm going to factor that. I have -16 at the top, and since there's no x value there, my b is 0. So the two numbers are going to be 4 and -4. So this is going to become this. Okay, and we're going to cancel what's the same. So I have an x plus 4 here and an x plus 4 here that I can get rid of. So I now have 2 over x minus 4 minus 1. So for asymptotes, the -4 that's down here, that's my h value, or my vertical asymptote. And remember that flip sign, so it's going to be a +4. And then the number in the back here, that is my horizontal asymptote, and that sign stays the same. So your x equals, that is your vertical asymptote, and your y equals is horizontal. So I've got x equals +4. X equals +4, and y equals -1. Your domain is -infinity to the vertical asymptote, union vertical asymptote to infinity. Your range is -infinity to the horizontal asymptote, union horizontal asymptote to infinity. Okay, so I've got an asymptote at y equals -1, and I've got one at 4. Okay, as for holes in the graph, I had x plus 4 was the factor that canceled. Okay, so solving and flipping the sign, x cannot be equal to -4. Again, on your calculator, you would be able to do this, but I'm going to do it by hand since I don't have a calculator. So this is my function, and I'm going to put -4 wherever I see an x. So as a decimal, that's going to give us about -1.25. So our whole is going to be at -4, -1.25. So we've got one about there. Okay, so my graph is going to look something like this. Okay, and this is the function that I need for my transformations. Okay, so the number on the top is a. Since a is 2, it's bigger than 1, I have a vertical stretch. On the bottom, I've got -4, but remember that's going to flip sign to a +4, so that's going to move me to the right 4. And then k, the number in the back, is -1. It's going to move me down 1. All right, last one. I designed the question in a really funky way, so everything ended up canceling. If you want to try number 6, you're going to end up getting y equals 8 as your line, and it just turns into a linear. So none of the ones on your test are going to do that, so don't get your hopes up too much. They're all going to be very similar to what we did on numbers 1 through 5. So I have your practice key posted on Google Classroom. If you want to try to do those on your own and check with the key to see if you did them correctly. I didn't make a video for those, but the key is available if you want to check if you did them correctly or incorrectly. Your test is only going to have 3 graphing questions on it. 2 of them are going to be very similar to what we did in this video. And then the third one is going to be similar to what's on the practice, where it gives you a function and then it asks you to describe the transformations. So the third one, you don't actually have to graph anything. You just have to say like it was a vertical stretch, or I moved left 3, or whatever it may be. Okay, so this concludes the graphing notes video. If you have questions, please ask me in class or shoot me an email.